So guys, welcome to the lecture series of data structure and algorithm in Python. So before starting, I want to subscribe Vouch Classes. Please like, share and subscribe Vouch Classes. So what we have discussed till now. So we have discussed that first of all we understood that why we need to understand data structure and algorithm, basically to write a good code. And what is the good code? We have understand the two properties of good code. First is readable, that we will discuss later, and the second one is scalable. And scalable, I have given already a good example. So that is basically to improve the time efficiency or time complexity, that is to make the code more scalable. So let's get started. So now I will teach you today I will teach you the methods that will improve the time efficiency of a code. So this is basically bigger concepts, and we will see what are these concepts. So let's take an example to understand this bigger concept. After this example, I am sure that you will get a good feeling of this concept and you will able to implement it. Okay, so let's get started. Okay guys, so series example, we have to calculate sum of first and natural numbers. Okay, so suppose we are doing it without any using any formula, just simply calculating it. Okay, bit by bit. So that I will call it as a naive approach. Okay, so if let take an example, if I have to calculate at n is equals to 5. Okay, so what will be the answer? How we will calculate? We will simply do 1 plus 2 is equals to 3, 3 plus 3 is equals to 6, 6 plus 4 is equals to 10, 10 plus 5 is equals to 50. Okay, so you can see that it was not a problem. Okay, it can be done. But suppose if I will give you n is equals to 15, so the problem becomes difficult. But yeah, we can do it, but it will take a time. But if I give you n is equals to 1000 or 10,000, it will become very difficult to calculate this by this naive approach. Okay, so in 10th and 12th class we were told a formula, that is sum is equals to n plus 1 by 2. Okay, so in this formula, if you put n is equals to 5, you will get the answer. Okay, similarly, if you want the sum for n is equals to 15, you put the formula and you get the answer. And similarly, if you put n is equal to 1000 10,000 also, you will get the answer in one go. Okay, so here you don't you are not bothered about anything, you just getting the answer in one go. Okay, but in the naive approach, what is happening, as your input is increasing, as your number of inputs is increasing, the time taken by the algorithm, or I say process, is very large. Okay, so I will say first method is a very naive approach, and second method is a very smart approach. Okay, so machine also machine also solve the problems like the humans do, but they have a property that they do repetitive things in a very short time. Okay, so saying this, I will show you how to tell machine or how to code this approach, both two approach, and how much time they take for all the inputs. Okay, so we'll see in the code. Okay guys, as we have already discussed the name method and the smart method, so now I am showing you. First of all, I want to inform you that this is a REPL.it is website, so you can go online and type REPL.it, and you can easily do some Python coding here without downloading anything. Okay, so first of all, this naive I'm going to run this naive method. So machine, how machine will calculate, it will use a for loop, that is for I in range 1 to 6. Range function, just it is a iterable thing, so you don't bother about it. Just you see that this is a for loop. This is the same thing that we were doing by naive approach, that is calculating bit by bit. So you see, I'm running it, you see what is the time taken by it. So answer is coming to 15 and time taken is 0.0005 seconds. Okay, so now if I will improve, increase the input to 200, so it will, time will increase. You can see that time is increasing 100 times. Okay, if I improve the input 100 times, you can see that the time is further increasing. So you can see that time is further increasing. So similar, this is in naive approach. As we are going to increase the input, our time complexity is going to increase, our time is going to increase rapidly. Okay, so now I'm going to the smart method. In the smart method, first of all, you can see that when input is small, the time is similar to our naive approach, but as I increase the input, like I'm increasing it to 100, you will see that time will be more or less will be same. Time is more or less in 10 to the power minus 5 seconds. Suppose if I increase my input further to 100 times, you will see that the time will again remain more or less same. It has become 10 to the power minus 4, just, but it has become, it is more or the less same. So in the smart method, we can see that we are not going to time is not going to increase drastically. It will remain more or less the same as we are going to increase the input. But in the case of naive approach, machine is also, time of the machine, time taken by the machine is also increasing. Okay, so this, in this way we can these are the techniques which we can use to improve the time complexity. Okay, so now I'm going to take two names, O of 1, O of n. Okay, so see that as it doesn't matter whether input is large or small, time more or less remains the same. So this technique is called O of 1 technique, or we can say this is the time complexity of O of 1. But in this naive approach, we can see as the time, as the input increases, proportionally our time is also increasing. Okay, so this we call as O of n approach. Okay, so we can say that O of 1 approach is better than O of n approach. Okay, so basically whenever you see a for loop in the code, so we can say that it is a time complexity of O of n. Okay, so in the next video I will show you more methods, and I will discuss which one is better and which one should be used when. Okay, so thank you. We will discuss in the next lecture.